The Earth's solid metal core does not revolve in perfect order with the rest of the planet, and a recent study reveals that it may have reversed direction. Seismic waves traveling through the Earth have shown that our planet's inner core may have stopped rotating over the last decade, and its rotation may be reversing. Our planet's core is a solid mass of nickel and iron that has been crushed by gravity into a sphere about 2,400 kilometers wide. This solid core is surrounded by an outer layer of liquid iron and nickel, which produces Earth's protective geomagnetic field, and then by layers of the mantle and eventually the crust. Due to decades of research by Earth scientists, we know that the inside of the Earth is arranged in this manner. They did it by studying the behavior and timing of seismic waves as they traveled around the Earth in the wake of earthquakes. While most seismic waves are absorbed by the liquid metal at the outer core, waves from very intense earthquakes can reach all the way to the solid inner core and back out. Scientists can examine different properties of the inner core by carefully selecting specific seismic waves. Repeating earthquakes, or earthquakes that occur in the same region at various periods, are very helpful for this. Because seismic waves arise in the same region, they should travel along the same patterns and therefore have the same form when recorded by seismographs. If there is a difference, it is due to a change inside the Earth. Seismic waves from large repeated earthquakes occur at different times. The best explanation is that the rotation of the core changes throughout time due to the rotation of the crust. That is, the core constantly rotates in the same direction as the planet, but it sometimes rotates faster than the outer layers, sometimes slower, and sometimes the rotations match up. New research published in the journal Nature Geoscience analyses many decades of data to search for patterns in the rotation of the inner core. In Beijing, China, researchers looked through data from 1964 to 2021 for repeated earthquakes strong enough to generate seismic waves capable of penetrating the deep core. Their results showed that the inner core stopped rotating relative to the crust around 2009 and 2020. It currently looks to be spinning backward since 2020. The same slowdown in the core rotation was identified in the late 1960s and early 1970s. The worst that can happen is that the duration of our day increases slightly as it takes around 86,400 seconds for the Earth to rotate once on its axis. The variation in the core's rotation runs from 0.2 of a second slower to 0.2 of a second quicker, roughly 0.00023% of the total. The apparent difference in day length associated with such rotation change is just around a millisecond. These are changes that we would never notice. They're big to the researchers, though, and they'll help them figure out even more about how our planet behaves. What's your opinion on this? Tell us in the comment section. And if you like the video, then please make sure to subscribe our channel. Thank you for watching.